right, we're going to be dealing with rational expressions to begin with. We're going to simplify them. We're going to add them, subtract them, multiply, divide them, complex, and then we're going to be able to solve them, hopefully by the end here. And the reality is there's no better way to do them. There's no patterns. There's no anything to it other than just to keep doing them. So we're going to do several examples in each of the sections that we go through. And one of the biggest components you're going to find is you have to be able to factor. Factor, 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 factor. You're always looking to factor first and then reduce stuff down. Because it is rationals we're dealing with, it is fractions. So we're going to start with a monomial fraction, which means everything's multiplied, nothing is separated, there's no plus minus signs. 6x squared y cubed divided by 2x squared y squared. And when everything's a monomial, we just look to combine like things together. So numbers with numbers, 6 over 2 is 3. Square and square, when they're alike, they reduce. If they're not, we subtract the smaller from the larger and keep it in its position. So whether it's top to bottom, numerator, denominator. All right, so let's look at something that does have some plus minuses. Here I have 8x cubed plus 10x squared minus 2x. What I want to do is I want everything to be multiplied. Much like this monomial, I could cancel things because everything was multiplied. Because of this plus minus, I can't do any type of cancellations. Everything must be multiplied. So I want to put everything I can into parentheses. One way to do that is to factor. So one thing I can factor here is a GCF of 2x. And then that would be multiplied to 4x squared 5x minus 1 all over the 4x. Now I put the 4x in the parentheses for no other purposes than just to show you that it's already multiplied. It's already combined. And matter of fact, I could even separate them out to show that these are all multiplied. Everything has to be multiplied or you cannot reduce it. It must be in parentheses because you're either going to get rid of an entire parenthesis or not. It's an all or none deal. You cannot take parts of it. So in this case, I'm going to take the x and I'm going to cancel that because it's in its parenthesis. Both of them are in parentheses and we're good. The 2 reduces the 4. This is in parentheses. This cannot be gone any farther, so we're going to get 4x squared plus 5x minus 1 all over 2. And you're going to leave it alone. Do not do anything else with it, because this is all, and you cannot do pieces. It's an all or none deal, so we leave it alone. All right, let's look at x squared minus 5x minus 6 over x squared minus 1. Now, as this stands, I cannot do anything because this numerator is all together and the denominator is all together. I highly recommend you put them together because if you try to cancel out x squareds, it's going to be a whole lot of red markings on your paper and a very irate teacher. Do not cancel out x squareds. It's an all or none deal. It's everything or nothing. And since these everythings are not alike, because you cannot do pieces, I must look to factor. So let's look to factor the numerator up here. I get x, let's see, multiplies to be 6 and subtracts to be 5. So minus 6 and a plus 1. In the denominator, this is the difference of two squares. So I'm going to get x minus 1 and x plus 1. Now I have in parentheses things that are exactly alike. An x plus 1 and an x plus 1. All of it gets to go. All or none. The leftovers, there's nothing I can do with because it's all x minus 6 and all x minus 1, and they are not the same. X's are not reducible because of plus and minus. That's why we use parentheses. That way we don't make a silly mistake of trying to cancel things that cannot be done. You can only cancel through multiplication, not through addition and subtraction. Let's try one more. X squared plus 3x over 2x plus 6. We can get a common denominator or a common factor of x on top, so that's x plus 3. On the bottom, a GCF of 2. If I take that out, I get x plus 3. Now in parentheses, I have things alike. They get to go away. So my answer, x over 2. And that's set number 1, strictly simplifying and reducing things down. Now you will be asked on the first part of set 1 to find a given value. That's just substitution, which you should definitely know by now. If I say a function and I say find f of 4, you should know that that just means substitute. And that's all you're doing. And then the next part where it says find the domain. So you set the denominator not equal to 0, and you say the domain is everything except, in this case, it would be 3. That's your domain. It's everything except your vertical asymptotes. So you set your denominator equal to 0 and find it, and then your domain is everything except that. And that's what we just covered in the previous sections before that. So there's set 1 for you.